Good morning, students. Welcome again to your online physics class. So, today we are going to cover the topic of potential energy from work and energy chapter. So, after covering this chapter, students should be able to show the understanding of physics concept of gravitational potential energy, recall and understand the formula, distinguish situations involving gravitational potential energy, and solve related problems involving gravitational potential energy. So, dear students, as we already have discussed about this table, that we have various types of energy, out of which we are going to discuss about mechanical energy in detail in this chapter. Now, mechanical energy is also divided in two different parts: kinetic energy and potential energy. Kinetic energy we discussed in last lecture, that is energy possessed by an object due to its motion. So today we are going to discuss about potential energy. So potential energy can further be divided into two parts. One is gravitational potential energy and another is elastic potential energy. So in our NCERT, in our syllabus, mainly we are going to discuss about gravitational potential energy. So what is potential energy? Potential energy is the energy possessed by an object as a result of its position or shape or configuration. If we are changing the position of an object, we are doing work on that object, and that work is stored in the form of potential energy in that object. Or if we are changing the shape or configuration and shape is the same meaning. If we are changing it, then that also stored in the form of potential energy, and then when it is released to do work, it does work. So SI unit, as the unit of energy is joule, so SI unit of potential energy is also joule. So there are so many examples in which the height of an object is increased and the shape of object is changed, due to which it gets energy, like when we lift a chair from ground to a distance, then we are doing work in lifting this chair, and that work is stored in the form of potential energy. Second, you sitting on third story of this building. So how you reach to third story? You have done work by your legs. You applied force and distance was covered. You walked till third story building, and therefore that work is stored in the form of potential energy. A stretched rubber band, a compressed stretched spring, a inflated balloon. There are so many examples which contains potential energy. So let us see with the help of these pictures. In this picture, picture number 1, you can see a person have raised the hammer. The same example we discussed in kinetic energy also. So how this hammer works? The person is applying force on the hammer and it is lifted to a height or it is displaced, due to which potential energy is acquired by this hammer. And when the hammer goes on the nail, then that potential energy is converting into kinetic energy. We are going to discuss about this concept in next topic, that the energy from one form to other form can be converted, and when it falls on this nail, then this hammer can do work. In the same way, in this slingshot, you can see that it is a string, elastic string, whose shape or configuration can be changed by the application of force. So when you stretch this string of the slingshot, you are doing work on that slingshot on this string to change its shape, and when you release it, then that work is converted in form of kinetic energy. Means energy can be converted into work and work can be converted into energy. In third example, you can say this boy is lifting this block, and for this it have to do work, and as this block in this case have some height, so due to height from this ground, this block is having potential energy. When this brick or this block fall on the ground, then it does work. In the same way, in case of spring, we are applying force from both sides. It means, and there is displacement in this turns. So force and displacement are there. So this spring is having stored potential energy inside it. And when we will leave this spring, then what will happen? That this spring can do work. Now let us derive the formula for potential energy. It is a very simple two-line formula only. For this, let us consider an object. This object is having mass m, and when we lift this object and we place this object at this position, let at a height h. So how this object is going to this height? That we are doing work on this object in taking this object to this height, and for that work done is stored in the form of potential energy. As we discussed in kinetic energy, that if work is done on an object to increase its velocity or to make the object move, that is stored in the form of kinetic energy. In the same way, if work is done to increase its height or to change the shape of object, that work is stored in the form of potential energy. So this is formula for work. W is equal to force into displacement. Let us convert this force into mg. M mass, g acceleration due to gravity, because we are taking it away from the gravity, and when we are taking this object away from the gravity, then work is done on this object. And we write this formula. In place of s we will write h, so it is mgh, or this is formula for potential energy. It's a one line derivation only. W equal to Fs, and we convert F into mg and S into h. So W equal to mgh, and this work is converted in the form of stored in the form of potential energy. Okay, now here is the definition of gravitational potential energy. As the name suggests, gravitational means due to gravity. So gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against gravity. Because we are taking this block against gravity, that's why we have to do work, because gravity is pulling this block towards itself, towards the center of earth, but still we are taking it to a height. So that work done by us is stored in the form of potential energy. So if in exam the definition of potential energy comes, then you have to write the energy possessed by an object due to its height or its shape. But if in exam the definition of gravitational potential energy is asked, then you have to write this definition, that is work done in raising the object from ground to a height against gravity. So, two important points we are going to discuss about gravitational potential energy. You can see this building, and the potential energy of an object at a height depends on the ground level or zero level you choose. As we discussed in chapter motion, the reference point. In the same way, in potential energy also, it depends upon that which point or which place you have located as the reference level. Suppose you are standing on this floor. This is ground floor, this is first floor, this is second floor. If you are choosing the reference level as the ground floor, then potential energy possessed by you is given by mg. Mg means your weight multiplied by h. So h is here to here. This distance will give you the height. But if you are choosing the reference level at this floor, the first floor, you are choosing your reference level on first floor, then potential energy possessed by you while standing on second floor will be given by the formula mgh, and h will be this much height only, means from first floor to second floor. If you are standing on this roof and you are choosing the reference level as the ground, then what will be height? This much. But if you are choosing the reference level as this floor, then what will be height? This much. And according to the height, you will write the formula, and your value of potential energy possessed by you will be given by the formula weight, that is mg, into h. H means vertical height from ground level to the upper level where you are considering, means between these two levels. Next is path is potential energy is independent of path. Independent of path means that it depends only on the vertical height between initial position and final position, and it do not depend upon the path followed by the object. Like this object is placed from point A to B, and this is taking path 1. But if this object is going firstly vertical, then going horizontal, then vertical, then horizontal, and then finally reaches to B, this is path 2. But no doubt the distance covered by this object is more in case of path 2. But potential energy depends only on the vertical height between A and B, the perpendicular distance between A and B, and which is same in both the cases. In this case and this case this vertical height is same. So the potential energy possessed by this object as well as this object will remain same, because its vertical height is same. So the same thing is written here, that it is useful to notice that the work done by gravity depends on difference in vertical heights of initial and final positions of the object, and not on the path along which the object is moved. Here a block is raised from position A to B by taking two different paths, and let height is h. So in both the situations, work done the object is mgh, that is same. So this is important question. Like in exam, two pictures can be given to you, like this, and question can be asked that in which case, in case 1 or in case 2, the object at a height is possessing more potential energy. So the answer should be that both objects is having same potential energy because both objects are at the same height. Okay beta, in work topic we discussed an example that a person or a boy is lifting the chair and completing the round or moving around in the class. So in that case work done is 0. Why work done is 0 in that case? Because the boy is completing the round and reaching to the initial position, and the displacement is 0 in that case. Work equal to force into displacement, so work is 0. Some student have asked this question, so I am giving the answer of this question. Now examples of gravitational potential energy. You lifted a set of books of mass 3 kg for 2 meter height. What is gravitational potential energy gained by the books? Take G equal to 10. Now we have given, for simplicity, G equal to 10. Otherwise, if it is not given, then we have to take 9.8 meter per second square. So gravitational potential energy formula is mgh. M is given, G is given, H is given. So directly multiply, we will get the answer, that is 60 joule. So the energy possessed by these books in lifting will be 60 joule. Now, in the same case, find the work done by you to lift the books. The work done, the formula is force into displacement, and the formula of force equal to mg. It is given, displacement is also given. So when we multiply, we get the same answer, that is 60 joule. So work done by you is same as the gravitational potential energy possessed by the object. So it properly proves that work done in lifting an object is stored in the form of gravitational potential energy. So better remember, if the energy possessed by an object due to increase in its height, that is gravitational potential energy, and if energy is gained by the object due to change in its shape, that is elastic potential energy. Now these activities are given in your books. 11.8 activity. These are very simple activities you can do at home also. So let us discuss. We take a rubber band and hold it at one end and pull from the other. The band stretches. What is happening? Its shape is changing. Now release the band at one of the ends. What happens? The band will tend to regain its original length. Always it happens. You must have noticed a lot of times. So this is because the band has acquired energy in its stretched position. When you were stretching this rubber band, you were doing work on this rubber band, and that work is stored in the form of potential energy. And when you will leave its other end, then that potential energy, stored potential energy, does work and regain its shape. Activity 11.9. So this is the picture of a slinky. Actually slinky is a long spring. It's a very flexible spring, and it can be spread to a 1 or 2 meter distance. It's a large spring. So in our lab also it's available. If you will come in the school, then I'll show you. So take a slinky as shown below. Ask a friend to hold one of its ends. So as it is a long spring, so it can be stretched. So its one end is held by your friend, and when you will stretch it to a large distance, you can see that its turns get open and the shape of this slinky go on changing. And your pens also, you must be having springs. In some ball pens, some springs are provided. You can check there also, it have a turns, and when you apply force on those on one end of that spring, then its shape get changed, it get elongated. In the same way in case of slinky. So how did the slinky acquired energy when stretched? Because you are applying muscular force on it and its turns get displaced. That's why it gains energy. Would the slinky acquire energy when it is compressed? That way also. Like this is its original shape, and if we are applying force in compressing, then also the work is done on it and it acquires energy. Activity 11.10. You can see this picture, beta. This is the inside part of a toy car. Earlier, the toys of the child comes to be in such a way that when we wind the key in that toy, then toy moves. These days, more toys are coming with the help of remotes and they work with the help of remote. But earlier, a lot of toys were coming like this. So, what was happening inside it? That this is a spring near this tire, and when we wind this key, what we were doing? We were moving our hand. We were doing work in winding this key, and that work is stored in the form of elastic potential energy. Means this springs, the shape of this spring get changed, and when we leave this toy, when we allow this toy to move, then again this spring regain its shape and it does work. So take a toy car, wind it using its key, place the car on the ground. Did it move? Yes, it moved because we have wind its key. In winding this key, the shape of this spring is changed, and when we leave it, then it regain its shape and it moves. It does work because along with this spring, axle and the tires are attached with this toy and this toy start moving. So this is also an example of elastic potential energy. In this activity, lift an object through a certain height. Okay, suppose this stone was lying here and now the stone have been placed at this height. So it begins to fall when released, and when it is released from air, it will fall. So this implies that it has acquired some energy. If raised to a greater height, it can do more work and hence possesses more energy. When we allow it to fall, then it will fall and it does work. Means force will be applied by it and displacement will carry out. And if it is carried out to a more height, then according to formula mgh, as it directly depends upon height, so more is the height, more will be potential energy possessed by this stone. From where this energy comes? But these activity questions can also be in your exams. A situation can be given that you lift a brick and place it on the first floor, and when it falls on someone, it hits or it does work. From where this brick acquired that energy? So that brick, when taken from the ground floor and placed on the first floor, then work was done on that brick, and that work was stored in the form of potential energy, that is gravitational potential energy in that brick, and that's why it can do work. So in this way you have to read these activities from your NCERT carefully. This is activity number 11.12. Take a bamboo stick and make a bow. You can see this is a bow and this is an arrow. Now this is a string. We know this string is elastic. So place an arrow made of light stick on it with one end spotted by the stretched string. Now stretch the string and release the arrow. So what is happening in this case? That this person is applying force on this string, and as it is elastic, it gets stretched, its shape get changed, and due to change in shape it acquires energy. And when this person leave it, then what happens? This pushes this arrow, and this arrow goes in forward direction. Means that stored elastic energy in this string is doing work on this arrow, and arrow goes in forward direction. So potential energy stored in board due to change in shape of the string, and thus used to form kinetic energy in throwing of the arrow. So that stored elastic potential energy is converted into kinetic energy of this arrow now. So this potential energy, kinetic energy, and other forms of energies also are interconvertible. So in our next class, we will discuss about conversion of energy and conservation of energy. So read this topic from your NCERT and write your notes and learn the notes. Thank you.